In this video, what we are going to do is to start the software Civil 3D 2016 in my case. Sometimes you may have some kind of other software. I told you to download Civil 3D 2018. So if you have Civil 3D 2018 version, you may have a desktop shortcut in here. So I want you to double click this Civil 3D 2016 in your case, whichever the version you use, Civil 3D 2016 or Civil 3D 2018, but I want you to click on the metric version. That is the version we use for in our work. So metric version is using the units as meters. So that is the units we are using in Sri Lanka. So that is why we are using the metric version. I want you to select this Civil 3D metric version shortcut icon and double click to open the software. After some time it will be loaded. Now you can see my Civil 3D software has turned on. This is the basic interface of Civil 3D software. So depending on your version, you may see some kind of small differences in the basic interface, but more or less this interface is same. So you will be seeing that you may have something called drawing 1, and I will now explain about the interface of Civil 3D. At the top left corner you have something called application menu browser. Once you click this button, you will see there are some kind of icons appearing on the window. So these are same as Microsoft Office or Excel. So by this you can open a new drawing. By this you can open an existing drawing. Here you can do save as, and some other functions. So if you have problems with any commands, you can type here and get details of that. So that is about application menu browser. Then here you have something called workspace. When you place the cursor here, it will be highlighting what it is. So here this is the workspace. There are several workspaces. Once you click on here, you will see there are 4 workspaces here. But what we are doing is Civil 3D workspace. Then you have some quick access toolbar buttons here. Here you can create a new drawing. You can open a drawing. You can save. You can print or plot. You can do or undo and redo things like that. You see these kind of things in Word, Excel too. So I think you may be familiar with these things. Then here you have the tabs: Home tab, Insert tab, Annotate tab, Modify tab, likewise. So most of the things we do is in the Home tab of Civil 3D interface. So inside this interface you have something called panels. So this is palette panel. You can see it has a border from the others. This is palette panel. This is create ground data panel. So inside these panels you have some other options. This is point drop down. Then this is surfaces drop down, likewise. Then you have create design panel. In that create design panel you have some kind of data. Then you have profile and section view panel. So each of these panel have specific Civil 3D data. In other tabs also you have separate panels. Here you have import panel, InfraWorks 360 panel, block panel, likewise. So I move back onto my Home tab. Then this one is called the tool space. This is where you have all the tools and data stored in Civil 3D. You can access all the stored data and settings in this tool space. In tool space you have 4 tabs: Prospector, Settings, Survey, and Toolbox. In Prospector tab you have all the data inside. You can view all the data within the Civil 3D drawing through here. So if you have point data, it will be showing here you have point data. So if you have alignment, it will be showing that you have alignment here. So I will show you once we go forward with the lectures. Then you have the settings tab. It has all the settings that we need to do work with Civil 3D software. Then you have the survey tab that will be useful for the surveyors, not much useful for engineers. Then you have the toolbox tab where you can use the report manager to create output reports from Civil 3D drawings. So I moved up to prospector tab where we work so much in Civil 3D. So if you couldn't find any of these tabs, you can turn it on or off through these buttons. If you click this button, your prospector would be gone. So if you click this again, your prospector will be appearing. So if you click this button, your tool space would be gone. So once you click it again, it will be appearing. So if you lose the tool space, that is how to get it back. Then you have model tab where we work. Then you have two layout tabs. So they will be used to get the output drawings, but we are not going to learn them inside this course. We are mainly working in the model space. Then you have the command bar where you type all the commands. So if you are familiar with AutoCAD, that is same as Civil 3D. So you have to type the commands here and you can do whatever the thing you want to do in Civil 3D, same as AutoCAD. For example, if you want to draw a line, you type line here in the command bar. So it will give you the line command. Once you press enter, then you can create a line like this. So this is a simple line which is a AutoCAD entity. So there is a difference between AutoCAD and Civil 3D. The major difference is Civil 3D is a more intelligent software. Civil 3D has intelligent objects. Once we go through the lectures, I will show you. It can change according to the situation once we change the parameters. But AutoCAD cannot do that. Civil 3D can do that. That is why we call Civil 3D a intelligent software. In here you have the help section. You can get help from anything you want related to Civil 3D or AutoCAD from here. Then again you can sign in if you have a when you want to log to the online account, you can sign in from here. So also you can use the online map through this function after signing in. So that is about a basic introduction about Civil 3D. Then in the next video we will learn how to set up Civil 3D interface to work with Civil 3D from here onwards. In this video, we will be starting a new drawing and synchronize the Civil 3D interface with my interface and your interface and making both our interface identical so that you will not be getting much problems while working with the Civil 3D videos. So before that, I have sent you an email related regarding the data we need to use in this Civil 3D lecture series. So you may have received something like this, CE760 Civil 3D. It is a RAR file, or other words a zip file. First you need to copy this to a place where you can easily access. I have copied mine to the desktop. Then you have to extract this using something like extract here. So you will be having this folder after extracting. Then you have to open the Civil 3D software, the metric version. If you have already done that, you don't need to open it again. You just go into the Civil 3D version. Now I am going to open a new drawing using a template. So a template means a drawing where all the standards and settings are stored to do our drawing. So in your company, if you are working in a company, they may have a Civil 3D template where you can use for your Civil 3D works. So various companies have various drawing templates to do with their Civil 3D work. So now I am going to start a new drawing with a new template. So what you have to do now is you go to the application menu browser, you click here and then go to new. Then I want you to browse to the file where I gave you, that is the CE3760 Civil 3D data folder. So that is in my desktop. I am moving here and I go into the template CE760 Civil 3D folder. So inside that you have data folder. In that data folder you have something called new road template. It is a file called new road template. So you have to open that file. So every time you start a new drawing, you have to use a new template file. You can use existing template file. Anyway, you have to use a template file. So I have opened this drawing too with the new road template file. So I will close this drawing 1. I click this cross sign and go to save changes. So there is nothing will be saved. Now my drawing 2 is opened. It is opened using the new road template. Now what I am going to do is I am creating some settings, or I am making some settings so that my Civil 3D interface and your Civil 3D interface become identical. So here what I want is I want to press your shift key on your keyboard. Press your shift key on your keyboard, then right click your mouse button, right click the mouse button, shift key plus right click, then you got snap settings, click here, then you will get something like this. You then uncheck this option, snap on, uncheck this one, then snap tracking, this one also uncheck, then you move on to this snap and grid, should be unchecked, polar tracking should be unchecked, object snap we already unchecked. It is okay to have these things checked, but main thing is to uncheck these two things. In 3D object snap, make sure it is also unchecked. Dynamic input, make sure this one is okay to have, but there is another settings to be changed. I will tell you next. So after setting all those things, you click OK. Now you just type some commands. You put your mouse cursor here somewhere in the middle, then you type some commands. So if your commands are typing on the command bar, that means your dynamic inputs are turned off. So to ensure that, or to change the dynamic input mode, you have to press F12 on your keyboard. So the modern laptops, you have to find F12 key by pressing function or Fn key plus F12. So make sure that what kind of keys are to be pressed to get the F12 key on your keyboard. In my laptop, I have to press function key plus F12. So in your laptop or computer, just make sure what are the keys to type to get the F12 function. So what I am going to do is I am pressing F12 on my keyboard. So nothing will be happen, but when you type, you will see the typing is happening where the cursor is there. So if you press F12 again, you will see the typing is happening on the command bar. So I want the typing to be happen on the command bar. That means your F12 should be turned off, or the dynamic inputs should be turned off. Now that is the main options what we have to be set to synchronize my screen with your screen in terms of Civil 3D. So you don't have to save the drawing in this moment, but keep the drawing open. In the next video, I will tell you how to start a project with Civil 3D for design. When you have selected the site for our design, what you do at the first, so once you have finalized the trial alignments and everything, as I told you in highway design lectures, what you do is you are going to survey that area. A surveyor will be going to that site, and he or she will be surveying in that area. We call it doing a topo survey. The surveyor will get the features in that area as well as the elevations by the means of points. So the surveyor goes there and taking elevations as points, and also he is taking the objects or features in that area. So the surveyor will give us the point file where we have the elevations. Then we can use that elevations to create a Civil 3D model. The points will be used to create the Civil 3D model, what we called a surface, that is the ground surface of that area where the surveyor has surveyed. So on that ground we will be creating a new road. So I hope all of you have this drawing open by now without closing from the previous video. So this drawing is open using the new road template which I have done in the earlier video. So now what I am going to do is import points into this drawing. So to do that, you have to go to Home tab. Then you have something called points here. You click this drop down. You go to point creation tools. Then small bar will be appearing. You can drag it here. Then you click this button, import points button. Then another small window will be appearing, that is import points window. Then here you can select the files. You click this plus sign. Then you go to your desktop. In my case, that is my desktop where the data are saved. So I go to CE760 folder and go to data folder, and make sure your file type is CSV, this type CSV. Then you will see inside this data folder, inside this Civil 3D data folder, topo survey points. You click this point, click this Excel file, this kind of Excel file, and click open. So In Sri Lanka, the surveyors are usually doing the surveying with a file format called PNEZD. That means point number for P. N means northing, E means easting, PNEZ means the elevation, D means the description. So you have to specify the point file format. So you have to go down here. You will see PNEZD, comma delimited option. Then you have to select that one. Then you will see I am dragging here to enlarge the window. So you will see the point numbers, northing, easting, point elevation and description in these points. So these are the points in this drawing. Even though you have small number of points here, it is only a preview. So you have so many points inside this file. So if the file is successfully imported, you will see a green check mark here. Then you have to put a check here, add points to point group. Then you click this to give a name for the point group we are importing. We say propose survey points. Then we click OK. So we will uncheck this option, uncheck the both of these options, and we click OK. So your point file will be imported to your Civil 3D, but you will not see anything at the first place because you cannot. It is imported to a location where we can't see in this screen. First, I will close this toolbar. Then I will double click my mouse wheel. You should have a mouse with a mouse wheel to do Civil 3D or AutoCAD work. Otherwise, it is very hard to work with Civil 3D or AutoCAD based softwares. So definitely you should have a mouse with a mouse wheel. So what you have to do is you have to double click the mouse wheel, the middle button. You have to double click the mouse wheel. Then you will see the points are appearing inside this drawing. If we zoom in here, you can see the point detail. This is the point number, this is the elevation, and this is the description. TE means tar edge, the existing edge of a road. So if we come here, this is the center line of a road. Likewise, you have so many points. You have some kind of this might be a boundary wall. So these descriptions, waypoint descriptions, will be given to you by the surveyor. Here you have tar edge points. This is telephone post. Likewise, you have so many points which are taken by the surveyor. So we have imported the points into our drawing. Now we are going to save this drawing with a name. To do that, I am clicking save here, save option here. Otherwise, you can go to application menu browser and click save. Then I am going to my desktop and go into this file, and not in the data folder, outside the data folder I will save my drawing as points imported. Then I click save. So up to this point we have imported Civil 3D points into the Civil 3D drawing. In the next video we will be discussing something called external reference. So we will be looking at that in the next video. Please don't close the drawing, so you can work with this drawing in the next video also. In this video, we are talking about a concept called externally referenced drawing. In the previous video, we have imported civil 3D points into our drawing where a surveyor has been taken the survey points and we have imported that points into our drawing, but we still don't know whether these points are imported to the correct location. There's no clue for us whether we have imported the points to the correct location. So to ensure that, we are doing something called externally referenced drawing. So we are going to do that now. First, I am going to save this drawing as a separate file. To do that, I go here, application menu, browser, then you go to save as, then you type the file name as external reference, then click save. Now what I am going to do is I am going to externally reference a drawing into this current drawing. To do that, I am typing xref in my command bar. Place the cursor in your command bar, then type xref, xref, and press enter. So you will be getting a small window like this. You can drag here and click here, this small drop down, click attach drawing. Then you go to desktop. In my case it is desktop, and you have to go to the Civil 3D data folder which I gave you. Then you click on this data folder here. Then click on this topo survey drawing. Click on this topo survey drawing and click open. So another small window will be appearing. Make sure this scale button is unchecked. This insertion point is unchecked. All these points are unchecked, and make sure the drawing units are meters. Then click OK. Then you will see there is a survey drawing appeared in our points drawing. It is an external drawing. It is not in this drawing. It is an external drawing. So we are creating an external reference, like we are looking something from a butter sheet. So we are something like that. So this is at the background, not inside this drawing, not on top of this drawing. It is inside the background. You will see the survey. So that is what you call externally referencing a survey. So if we have done something wrong in our point import option, that means if we have imported the points to a wrong location, so this survey and the points will not be coincide with each other. That is how you make sure that your points are imported to the current location. So if your both survey and points are at wrong locations, we can't help for that one. But if they are at the correct locations, but we have done it in the wrong, if we have done it in the wrong way, we can make sure that we have done something wrong by external referencing a drawing. If we have done something wrong, this external reference drawing will not be coincide with this drawing. So I will close this external reference manager. Then you will see the points are these star edge points. That means the edge of the road points are connecting through a line. Then you have the we have some other lines also. Here you have another road going outside. Likewise there you have building edges. So that is how to externally reference a drawing. So if you don't need to see this drawing, you can unload it. So to unload it, you type xref again in your command bar, and you go here or press only xref, and then press enter. So to avoid to hide this survey, you have to unload this one. Right click and unload. If you want to reload it again, you can reload it. Unload and reload. Likewise, if you want to remove this drawing from this, remove this attachment from this drawing, you have to click this detach button. But I am not going to do it. So instead I can do unload for a moment if I need. Otherwise you can keep it with you by reloading the drawing. So that is how you create an external reference to a working drawing. So in the next video we are going to create a ground data model or ground model from the imported points. In this video what we are going to do is we are going to create a surface or the ground data model from the points we have imported. Before that I will change this drawing name as create surface. To do that I go to application menu browser, then go to save as, and I change my name as create surface, and then I click save. So it seems like my external reference is making little bit of a problem here, so I will hide this one. To do that I type xref in my command bar, press enter, then I click this topo survey button drawing and right click unload. Then I close this external reference manager. Then what I do is I go to prospector, then here surfaces. Make sure you are going in the prospector tab, then surfaces, right click, then create surface, and your type would be thin surface, then the name would be existing ground. Let us say EG existing ground. You can say the description as existing ground. So this surface will be displayed as with a contour style of contours 2 meter and 10 meter background. You can change them later. For the moment I click OK. So still we have created a name for the surface. We haven't added any data to this surface. To do that, you go to prospector again and surfaces. You will see that now it is populated with the name called EG, but there is no data here. In my first videos I told you that whenever the data is available it is showing in the prospector. In my drawing we have civil 3D points, so it is giving me a bullet sign here. It's giving me a notice that we have points here. So these points are shown in this preview area. So if you drag it somewhere up, you can see the point number noting listing will be shown to you. So that is happening when you have points. But here we have only the surface name. You don't have any data here, so it will not showing in the preview area. So in this, what we are going to do is we are going to we are going to add data to our surface. To do that, I go here, expand the surface, then you have EG, I expand it again, then you have definition, we expand that again, then you have something called point groups. you right click there and go to add. Then you have two point groups where you have, that is all points and topo survey points. Both are same, but you have to select the topo survey points, that is the point group we have imported in few minutes earlier. So I select topo survey points and click OK. You will be seeing that the surface is appearing on your drawing. So this is the surface, these are the contours, this is the ground data surface. So I will, if you got a message like this, you just click here to turn off that one. Then you click somewhere in this gray output or this green line and right click, go to object viewer, then you can maximize this one using here and just drag the mouse. You will see some kind of a 3D model in this area, so you can change the type from here, so then you will see the things very clearly. So you will be seeing now there is some kind of a road going on the middle. You can see it here, some kind of a road going in the middle, and I will close this for the moment. And you can see the surface, this green area is the surface border. So you can see the point details are in this area, but the surface is also appearing in this area. So there's something problem is there. So without point detail you can't have a surface, but just connecting these points from this point to this point, it is creating a surface. But at the middle of this area we don't know what are the things are there, so we can't say this in this area the surface is correct. It should be going like this where you have the points. So you have to correct this one. To correct this you need to apply a boundary to this surface, so that we are telling the surface you have to go within the boundary we give it to you. So that boundary would be the edge of the points in our drawing. So to get the boundary, I want you to go to the drawings folder. That means you have to go to here this application in your browser. Then this time you go open and go into your Civil 3D data folder. Then you have something called boundary. Then click open. So you will see a boundary like this, a polyline like this, that is a boundary. So what you have to do is to select this one, then right click, go to clipboard, then select this one, copy with base point. Then it is asking a base point in the command line. Type in the command line 0, 0, 0 and press enter. So it will be copied into your drawing, into your clipboard actually. Then you move on to the create surface drawing. Create surface drawing where we have the surface. Then right click, go to clipboard, then go to paste. So it will be asking paste specify insertion point. So click there and type 0, 0, 0 where you type for base point, similar as that one. Then press enter. Then you will see some kind of a boundary is appearing in the drawing. So even though we copied a boundary, it is not appeared, it is not applied into this drawing yet. So we have to apply it. Now to apply this, what we have to do is you go here, surfaces, then you go to EG, expand it, then you go to definition, then you go to boundaries, right click and go to add. Then write your name as outer, then uncheck, don't change these options, click OK. Then it will be asking in the command line, select an object. So that is asking to select a boundary. Now zoom into your drawing and select this yellow colored boundary copied earlier. This yellow colored boundary copied earlier and click it. So you will see your boundary is shrinking into your drawing. So shrinking into your new boundary, your old boundary is shrinking into your old new boundary, so that you give the drawing a new realistic view without the unrealistic edge initially posed in this location. So that is about creating a surface. In the next video we will be talking about applying break lines and exporting and exporting the surface to a Land XML version. In this video what we are going to do is something called adding break lines to a surface. So that is something important when you are doing a civil 3D work. When you are creating a civil 3D surface, especially, you have to add break lines. Break lines are something called items where you know the surface changes at a definite point. So I will show you that. To do that, we have to change this drawing name as add break lines. So I go here and click save as and change the name as add break lines. Add break lines, click save. Then again I am going here and going to open a new drawing. So in your data folder you have tar edge and centerline lines. That drawing, click that one and click open. So you will see something called, you will see the tar edges and centerline of the road, existing road in the drawing we are working with. So it is extracted to a separate place in here. So it is giving only these lines in this drawing, but you see here it is showing these lines, these center lines. We are marked as a line, so it is giving those lines in a separate drawing. So what we are going to do is we are copying this line into that drawing. So to do that, select all the objects, right click, clipboard, copy with base point, then 0, 0 will be your base point. Click enter, then go back to your add break lines drawing, this drawing, right click, clipboard, paste, then you type 0, 0, 0, 0, 0, 0 as your insertion point. Press enter, you will see the lines are coming into this drawing. So what we are going to do here is, we know that within the edge lines and center line, that means within the existing road, the road have a definite shape, because a road have a definite slope and definite shape within the road edges and the center line. It is different from the existing ground. It has a definite shapes when it comes to the road. So if you think of a dam, it has a definite shape. So where the slope of an object is, where the slope of an object can be identified without any problem, we call that line as a break line. So you can identify the edge of the lane and center of the lane easily. So we call them as break lines. In terms of a dam, top of the dam will be a break line because you can see at the top the slopes are changing from that dam edge line. So that is how to identify break lines. If you consider of a channel or an irrigation canal, you will see the bottom of the canal, the slope changes, and at the top of the canal also slope changes. So those lines would be break lines. So here we have the road edges as our break lines. So we will be applying them into the surface to get a more accurate surface. So to make sure that we are getting a more accurate surface, I want you to click this one of these contour lines. So you will be getting whole surface selected. So you will have to be seeing something like this, thin surface EG. So if you don't see something like this, press escape button on your keyboard. Then again select this line. Then you will see this. Then right click and go to object viewer. So once you just click this, drag this mouse somewhere here, you will see some kind of a road is going on the middle. Even though it is going, you can see the road is not smooth. Even though you can see a road, the road is not smooth. That is what we see at the moment. When I press close here to close that one, then I select these three lines. That means this red line, this light blue line, and the pink color line. Only these three lines and all things will be selected. Then I go to prospector, surfaces, EG, and then definition. As we go earlier, we click break lines, then go to add. As the name we type break lines, and your type would be proximity, and you click OK while they are selected. There will be a small error, but you have to ignore that. It's a minor problem. Then what I do is I click this contour line, one of the contour lines. So you will be having something like this. Then again I right click and go to object viewer. Then I again see my drawing. Now you will see a more clear road in the middle. In the initial option, your road is something not like a rough surface, not like a road surface. It is something like a rough surface. Now, even though the outside of the road looking rough, but the center of the road looking more smooth now. That is because of the option we gave by a break line. So that is the importance of break lines in Civil 3D. I close the object viewer in the previous step. So you will be having this kind of drawing now. So now you know what is the importance of break lines. In the next video we will see how to export our surface into Land XML. So far we have imported points and create a surface. After that we added a surface boundary, then we added break lines to the surface and made the surface more realistic. And so far we have done with the surface. We have completed everything with the surface. But when you are working with the surface, if you see all these point data and break lines in your drawing, it will be a burden to work forward from that drawing, because you will see all these things inside the drawing and you can't properly work. So in that case, what we are doing is we are exporting this surface, something called Land XML or some other version, and make the surface more user friendly so that we can work without much of a trouble of the data inside the surface. So first part, we are going to export this surface into a Land XML version. That is kind of a Land XML is kind of a file type which we use globally to transfer data. So this drawing file would be the drawing file which contains the surface would be transferred to a file type called Land XML, where other Civil 3D users can use the surface without seeing these point details and break lines and boundaries, all those things. In the Land XML version, what you have is the final surface only. It will not have the point data and all that. So that is kind of, if you remember, a slab of a building. When you are building the slab, you have all the formworks and all the jacks and all these other things we are using to form this slab. But after forming the slab, we will be removing all those things. So by Land XML also we are doing that kind of thing. We are removing all the unwanted parts of the surface and we are retaining only the needed parts inside the surface to work with the surface more easy and convenient manner. So to export the surface into a Land XML version, you go here to Prospector, Surfaces, then you go to EG where your surface lies. You right click here, then go to Export Land XML. After that, you will be seeing a check mark here, Surface and EG. Then click OK. Then you can go to the existing folder outside. Then to type the name as EG because your existing ground surface is there and your file type will be Land XML. Then click Save. So your surface would be now exported as a Land XML surface. So far what we have done is importing points, create the surface, add the boundaries for the surface, add break lines to the surface, and finally we exported the surface. So now we are going to close everything, and from the next point onwards we are importing the exported Land XML surface. That means we took the surface out of the drawing. Then in the next video we will take it into the drawing. Actually it will be into a new drawing, not this current drawing. So after exporting this, I want you all to close this drawing by saving it. In the last video, we knew how to export the surface to a Land XML version. In that, we created the surface from points and we added boundaries and then we added break lines and finally we exported that surface which has all those boundaries, point data and break lines to a file version called Land XML. In this video we will learn how to import that into another drawing. So to do that, I want you to open AutoCAD Civil 3D, whatever the version you have. However, you have to open the metric version. Then what you have to do is you have to open a new template from the template I have given to you. So here I go application menu, browser, then go new. Then I am in my desktop where I have the data folder. I select new road template and click open. So a new drawing with new road template will be opened. I will save this drawing as import Land XML surface. So to do that, I go here, then save as. I'm going to my Civil 3D folder, then I save it as import Land XML surface, then click save. So only we have saved the surface. We don't have any data in here because we opened a blank drawing template. So since my drawing name says that import Land XML surface, I have to import the surface into this drawing. Import means we are getting something from another source. So that source is a Land XML surface. So to do that, I am going to this insert tab here in the ribbon insert tab. Then you have Land XML. Depending on your version, it may be different, but the view may be different, but you may find in the insert tab Land XML. I click here. Then I go to my desktop where I save that Land XML file called EG. Then I select it, then click open. So you can see a small window appears. You don't have to do anything to this. Just click OK. Now our surface will be appeared in this drawing. You can see the break lines are appeared in white, so that you can get an idea where the break lines are. But they are not necessary to this surface. So you can delete these break lines. To delete them, you just click them and delete. Press delete on your keyboard. You will see now those lines are disappeared. These lines are actually contours. You can't delete them. So once you select these lines, you will see it appears as thin surface EG. That means it is selecting the surface. So currently the surface is viewed on contour. You can change the view of the surface. Before changing the view of the surface, you can see my surface is still selected. I press escape to deselect the surface, so it will not be selected anymore. So you can see now there is only a surface. You don't see any boundaries as we applied earlier, or you don't see any point data here. So this is a more simplified surface. You can't. Initial surface was a kind of complex surface because you have all the way, you have the point data and you can't see them clearly. You can't see the surface clearly. You have point data all the way. So this surface is kind of a less complicated, a simple surface which would help you to work with
very easily than the previous surface. So that is why we are using the Land XML conversion to create less weight or lightweight surfaces. Now I am going to change the style of the surface. To do that, I click here, then right click on my mouse button, then I go to Surface Properties. Then I go to Information tab here, Information tab. So I can change the style here, surface style. Currently it is contour 2 meter and 10 meter. So you can change it to contour 1 meter and 5 meter. Then you click apply, you will see the changes here. So you can use other design types and apply and see how they work. So this elevation banding means elevations, the surface is colored according to the elevation. So the slope banding is elevation, so the surface is colored according to the surface slopes, likewise. So for the moment I will keep this style as border only, so that we will see only the border of the surface. So now you will see only border of your surface. So that is how you import a surface to Land XML. In the next video we will look at how to create an alignment inside this surface to create a new road to our project. In this video what we are going to do is we are creating the background to generate or create an alignment within this surface. So before that I have to tell you we are still on the import Land XML drawing. So we imported the surface and we set the surface style to border only, but we haven't saved the drawing. So I will save the drawing from here, or otherwise you can do it from here. Initially we used save as option. Now since we are in this drawing we will use the save option. You can use this option, or else you can use this option, save. So I will use it here, save. So this drawing will be saved. So in any time if you want to exit from the drawing, you can save the drawing and exit from the drawing and reopen the drawing in a later time. So since we have saved this drawing, I will save as this new drawing. Save as this drawing for a new work, that means to create alignment. So I rename the drawing as create alignment and click save. So now in this drawing what we are going to do is we are going to create an alignment. Right. Now before creating an alignment we want to know the topo survey of this area. Even though we have a surface, you can't see any topo survey details. So to get that we want to external reference the topo survey as we did in a previous video. So to do that I will type express in here, then press enter. So the Express Manager will be opened. From here I click the drop down here and go to attach drawing, and in my data folder, in the field page data folder, I have propose survey drawing, I will select that and click open to access the drawing. So make sure you don't have any of these options checked. They should be unchecked and you have to click OK. So your surface proposed survey will be appeared inside the surface. So I will click this one and close that. So what we have to do is you have to create an alignment within this surface area, because that is the area we have the survey data. Currently we have existing road within this survey area. So what we are going to do is we are creating an alignment very close to the center line of the existing road. So the center line means this line. You can see throughout the drawing you have the center line. So what we will going to do is we are going to create an alignment thinking to coincide with this existing center line. We cannot 100% coincide this thing, but we can make this as same as possible. So when you are creating an alignment, you need to know what kind of a road you are going to create or what kind of a road you are going to design. Those data should be given to you, otherwise you don't know what kind of the data someone needs. So you have to request that data from the person who required a road from you. In this, I have prepared a small data sheet where you have the road data. So I will show it to you so that you can get an idea what kind of a road we are going to design in the next few minutes on this video. So this will be your road design summary. You have to design a road which is a two-lane, two-way road. So two-lane, two-way means you have two lanes and one side for one direction, the other side for other direction. That is what we call two-lane, two-way road. So your design speed would be 60 kilometers per hour. Then your lane width would be 3.5 meters. Hard shoulder would be 1 meter. Soft shoulder would be 1 meter. Terrain type would be a flat terrain. And I assume that you have to do this like a local RDA road, two-lane, two-way road. So you have to use RDA design guidelines. You have to follow RDA design guidelines to create this road. So when creating the road, you have given a pavement design thickness. When there is a part you need this one in road designing. So you need this pavement design value. It is given as bearing cost 50 mm, binder cost 50 mm, base cost 200 mm and sub base cost 250 mm. So we will be going to use this data later in the Civil 3D video. Now we will move on to the drawing again. So we have to remember that we are going to create a road which is 60 kilometers per hour design speed, and it is a two-lane, two-way road, and we have to follow the lane width and hard shoulders applied here. So now I am again inside the drawing. Now we are going to create an alignment, but before that I have to tell you, you have to do a lot more things if you are going to do a real world example, because you have to go to the site, you have to identify the constraints and identify the key locations, and you have to place the alignment to satisfy all those needs. But here what we are going to do is we are just looking at the topo survey and place the alignment for the sake of this exercise. Now, to create the alignment, you have to go to Home tab. Then you have this alignment here. Go there. Click the drop down. Go to Alignment Creation Tools. Alignment Creation Tools. Click that. Then a small window will be appearing, which is Create Alignment Layout. So the name of your road would be, let us say, Design Road. Then for the type would be Centerline. For the description, let us say 2-lane, 2-way road. Then again you can say L, which is width equals 3.5, arch shoulder equals 1 meter, and top shoulder equals 1 meter. If you like, otherwise you can just make this blank. So your starting station would be 0 here. So if you are designing an existing road at a middle section of a road, so if the station or the chainage of that location or the length up to that point is, let us say, 5 kilometers, you can start from 5 here, typing 5 here. So these are given in thousand, which you go start at 5th kilometer, you have to just type 5 here, 5 plus 0, 0, 0 to indicate 5 kilometers. So at the moment we think we are starting from 0 station. Now you don't have to worry about the site condition here. What you have to do is get this alignment style, which should be new road design style. Then alignment labels, it would be new road alignment, minor and major, minor and geometric points. Then you have to click OK. This kind of a small toolbar will be appeared here. So then what you have to do is you have to create the road according to the existing center line. We are trying as much as possible to follow the existing center line. So what I am doing here is I am going to identify the straight sections first and create curves in the middle. So first I come here, I draw 6 line 2 points, 6 line 2 points option, I get the 6 line 2 point option. Then I go here, I place the mouse close to the center line and I click. Then a line would be starting to appear. Then I drag the line until it is going to be very much straight. So I will stop somewhere here. Now I have one part of the straight. So it is okay to have them here. And one more thing I have to tell you, it seems like this is very small. The stations are very small. So you can do one thing you can do is you can change the scale. You can change the scale here. Usually we are working with a scale of 1:1000. 1:1000. So then you will get a more viewable view of the drawing. The these labels getting more clear now. Now I have create one section of the road. Sometimes it will go outside. So if you think you need to change it, you can just drag it here and you can change it like that. So it seems like you have a curve in this area and a straight in this area. So what I am going to do is I will create another straight here. Yeah, I see like there's a straight. Okay. Now I have to place a curve in between these two straights. I have one straight here, I have one straight here. So I will be placing a curve within this area. So I go here, then I go to this option, free curve fillet between two entities through point. I click that one. Then in the command bar it is asking select first entity. That means the select first part of the road. This is the first part. Then it is asking the next entity. Next entity would be this one. Then I have to click here. So I have to move my cursor. You will see small curve, blue color curve will be appearing somewhere when you click the mouse button. So once it is okay, you press enter. So if you feel this should be changed somewhat, you can even do the changes after the alignment is created. So far we have created a straight, then a curve, and then another straight. You can see the labels of the road are automatically placed along this alignment. So it is starting from 0 up to this point. We have a road about 488 meters long. Again, now I am going to create a new straight which I can see it from here to here. So I go to this option, 6 line 2 points. Then I select somewhere here and I select somewhere here which I see like I am getting a curve. Then I press enter to stop that one. You can see the stationing or the changes are not continuing to this point because this area is discontinuous. So that one is okay. We have to add a new curve here. Again I go to curve option, free curve fillet between two entities, 2 points. Then it is asking in the command line select first entity. I select this red color line. Click that red color line. Then it is asking the next entity. I will select this red color line. Then it is asking a place where my curve goes. So I can choose a place where my curve supposed to go. Just say I am picking somewhere here. Now up to this point I have created some part of my alignment. Then I see there's a big curve within this area. Here I have to be more careful of because I don't know whether I can cover it with one curve radius or whether I have to use a compound curve. So this time I will do some kind of a different approach. Rather than getting a new straight here and connecting this one, what I do is I go here and I use this option, floating curves, more floating curves from entity end through point. I click here, then it is asking select entity to attach to. This is the entity where we going to attach the new curve. I click here, then so you can see I can't go in the same curve with one radius, so I have to stop somewhere here. Let us say I will stop somewhere here. Then I go with a straight, looks like a straight is there. So I use this. Now I can't use fixed line 2 points because it is end of a curve. So I have to use floating line from curve 2 point. When there is nothing at the start, when there is nothing at the start of an entity, you can use fixed entities. If there is something at the start or something at the end, you have to use floating entities. Especially if you have something at the start of the entity, you have to go for a floating entity. Since we have a curve at the start, you have to go to floating line option. You can remember here at this point I went to floating curve option because I had a straight here. In this I used floating free curve fillet option because I had entities both sides of this entity, because that means when I draw this curve, I had this straight at the start, I had this straight at the end. So I go with free curves. That means you have constraint at both sides. For floating curves or floating lines, you have constraint at one side. So here you have to go to a floating line because you have a constraint at the starting side, and the inside we don't have any constraint. So I go here, floating curve from through point. Then it is asking select the entity to attach to. So I select this one. Then it is asking what is your endpoint. So I will be selecting somewhere here. So it is hard to select because of the curve type. So sometimes we have to go outside the curve. Let us say we will stop somewhere here. It's like we are getting a very sharp curve. Now then again I will go with the floating curve option, or otherwise I can use this. First I can use this straight section. I can create this straight section. Since I am creating it from here to here, I don't have any constraints, so I can go with the fixed line 2 point option. I click here and I click somewhere here at the end, then press enter. Now my end is okay. Now I have to have a free curve here, free curve fillet here. Then I go here, free curve fillet between two entities, 2 point. I select this one as my first entity and select this one as my second entity, and I have my curve somewhere here like this. It is not readily following the existing road center line, so I will make it as much as possible. So you can see here I have a very sharp I have a compound curve here turning at the same direction and with a small straight in between. So I will try to modify this in the coming video. So up to now we have created an alignment. Actually this is a kind of trial alignment. We don't follow any standard. We just create the alignment according to the road. Now in the next video we will see how to modify the alignment according to the design standards. In the previous video I have told you how to create an alignment to match with this existing center line of the road. Now in this video what we are going to do is modifying the alignment according to the design standard. So you can do it with first you can, when you are designing the alignment, you can do the guideline part along with the design alignment part, but in this case I have designed the alignment first and I am applying the guideline at the next step so that you can understand the things clearly. But when you are getting familiar with these things, you can apply the standards on as while you are designing the alignment at once. So before doing that, I will close this toolbar and I will close this drawing. Then I have to save the drawing. So I close the drawing. Then I open it. To open this, I can use it here, or else I can go to open option here. Then I go to create alignment drawing and I will open it. Now in this video what we are going to do is we are going to modify the alignment. So I will save this drawing as modify alignment. Then I click save. So before modifying the alignment, you have to have an idea what kind of a road you are going to design. So you already know you are going to design a two-lane, two-way road at a speed of 60 kilometers per hour. So I told you you are going to follow the RDA design guidelines. So now when you are following RDA design guidelines, so what kind of data you need to create the alignment? Now we have created the alignment without thinking any of that. We have just created the alignment. So now we will see what are the parameters we need to design this alignment. I told you that we are designing this road in a flat terrain. So whether it is an open area or a built-up area, your super elevation, maximum super elevation would be 6. You can't go beyond 6% super elevation in this road. So that thing has to be in your mind. Then the super elevation thing. So since we are doing at a maximum super elevation of 6% and we are designing the road for 60 kilometers per hour, this is the area you can work with. 60 kilometers per hour up to 6 points super elevation. So you have to use a minimum radius of 130 and more than that to design your road. So if you use 130 radius at that point, at that curve, your super elevation would be 6. If your radius is 135 or greater than 135 and less than 145, your super deviation would be 5. Likewise, you can go up to here. If the radius is more than 155, your super elevation would be 2.5. But if your radius is more than 810, let us say this is a built-up area. So since it is a built-up area, your adverse cross fault is at 60 kilometers per hour design speed. Your adverse cross fault will be 630. So when your curve radius increases more than 630, you will be having a normal crown for the road. That means you will not be having super elevated road. Your road will be like a normal crown road or normal super elevation road. So whenever the curve radius is greater than 155, your super elevation would be 2.5. But if the curve radius is even greater than 630, your super elevation would be minus 2.5. That means it will not be 2.5 super elevated. It will be at the normal cross fault side. So those are the things you have to memorize. This maximum super elevation thing, you can go up to 6%, and this is the minimum radius you can use for each super elevation, and this is the adverse cross fault radius for a built-up area where we design this road. So we will move on to the drawing and see how the things are there, because we already have a created alignment. We don't know how we have created that alignment, whether we have followed the RDA guidelines for 60 kilometers per hour or we haven't followed it. So we will check it now. Now I have this alignment. Now I am going to edit this alignment so that I get the design alignment to be complied with the design guideline. So to know these things, I have to know what are the radius values here. So according to the guideline, I have to use a minimum radius which is greater than 130 meters to have a 60 km per hour design road. So we will see how we have designed road up to this point using it without thinking of the guideline. So now I am going to know what is the radius of this curve. So to do that, I click here, select the alignment, then I go to here, geometry editor, and you will be getting this alignment layout tools which was used to create this alignment initially. So when you are creating the alignment, accidentally if you have closed this one, you can get it back by selecting the alignment and go to geometry editor. So if any case if you see these all things are grayed out, so you can't select any of these. If that occurs, you have to close the drawing and reopen it, so it will be fine by that. So now I am going to set this curve radius. I click here this pick sub entity button. A small window will be appearing on the side. Now I am going to select this curve, blue line, and you can see my radius is 860.201. Since this is kind of an odd radius, I am going to change it. Also, I can see my center line is too far from the alignment center line here. So I like to kind of change the alignment so that this part comes here. So to do that, I press escape. Then to do that, I want to delete this curve. So I am doing kind of modification to the alignment. So I have to delete this curve. Otherwise, if I shift these things, my whole alignment could be shifted. Will be a problem. I will delete this curve first to disconnect this alignment from here. To do that, I click here. Then I click this one. So my curve will be gone. And I will shift this straight section or the tangent section somewhere here. So then I will be having a small gap here, but I think it is okay since my curve coming inside this area. So I have done that shifting part. Then I go here to create the curve. To select between two entities. I click this one. To casting the first entity, I select this red line, which here. Then it is asking for the next entity. I select the next red line and I am marking the alignment somewhere here. Now we click more close to the center line. Since it is okay, I press enter. Now again I am going to use this pick sub entity editor and select this curve. So now I see my radius is 676 and you have so many other data for this curve, but I am worrying about what I worry is the radius. So I wish this radius to be some kind of a rounded value. So what I do is I change this parameter constraint lock to false. So then your radius will be activated to have some kind of edit. So I will change this radius to, let us say, 800 and see what happens. You can see it is a slight change in the alignment, which is not a bigger thing to worry. So I will keep it at 800. So the beauty of the Civil 3D software is once you apply the modifications, it will show the results straight away. So if I type this as 600, it will show me a radius of 600. So now you can see two things here. If you apply the 600, it will look like this. If you apply 700, it will look like this. So what option you go with? So if you apply 600, you get this kind of a road. If you apply 700, you have a small shift here. If you apply 600, you have a small shift very close to the center line. But in this case, what you have to memorize is the adverse cross pole. Your adverse cross pole would be 630. So if you go more than 630, you can avoid super elevation in this section. That means you can go with normal cross pole. So if you stick to 600 radius, you have to apply super elevation. So since this is a larger radius curve, I can increase the radius. So I use 700. Otherwise, you can use any value greater than 630. You can use 650 also. Let us say we put 750. So that may be very close to the existing center line. So that is that we are switching to 650 and I press enter. Now this curve is generated. Now I am going to this curve. This one also have some modifications from the center line, but let us say what are the parameters. So I click here, fix subbend area editor. Select this one. My radius is 285. So I wish to modify that radius. So here and let us say we change it to 250. Otherwise you can change it to 200. So when you are doing it, when you are lowering the radius, you can see this is going towards the houses. So I have to increase the radius a bit. Just see what is happening here. Now it's kind of okay. We use 280 maybe, much better road. So I will stick to 280 at this case and I press enter to complete that one. Here you have another two curves. Here you can check what to do. I click here and click this curve and you can see this radius is 323. So I go to here and make it false and let us say it is 300. Seems okay. And we go to next curve. So without entering or without pressing enter, you can straight away go to the next curve because it is asking select sub entity. So you can go to the next curve. So it will be given the values here. So it is giving these values for us. Now one thing I have to remember here, this radius is 300 and this one is 147. So 300 means super elevation 2.5 because any radius of a curve which is greater than 155 meters and less than 630 would be 2.5 super elevation. So currently this is 147. So it is less than 155. So you have to apply a super elevation greater than 2.5 maybe. You have to look at that table and find what is the value. So instead of that, I will increase this radius to 155 and see what happens. So you can see this is going a bit far away from the existing road. So I can't go that much because it is going far away. I have to reduce the radius. Let us say I reduce the radius to 140. You can see in this area I have another problem because the road is shifting too much. So instead of doing that, I'm thinking of having another straight somewhere here and have two separate curves. So to do that, I will press this button and I click here and close this. Click here and delete this entity. Then press escape. Let us say we have a small straight section here. So I use fixed line 2 points. Then I create this straight section here. Then again I will modify this one also. I select this red line, and from this grid I can modify it. Then I go here, go to free curve select option, select this red line, then select this other red line, then can use this area as my curve and press enter. So I am okay with that curve. Let us say what is the curve radius. I click this fix up density one, then I click here. My radius is 60, which means a very low radius where I cannot even use for 60 kilometers per hour speed, so I have to increase it. Let us say I use 130, so definitely I have to use this curve to go to 130. So there is no option for the moment. So instead, what I do is I delete these two curves which I created, and I am going to follow this three curve select again to use this single curve as which was earlier. Okay, so I will change the parameters here. It was 100. Let us say we change this value to 140. Okay, 140 would be good because we have a house here. We don't have any houses in this side. This is very close interval. So let us say that kind of a good way. Otherwise, you can go with 145 option. Let us say that one is better. 145 is better. So I click enter to close the alignment. So we have finalized the alignment. So you can view all the alignment entities at once by clicking here. So this parameter editor or alignment grid view will be appearing. So you can see all the radius values we used and the length of these curves as well. So if there is an error, you will see some kind of a warning sign here if you haven't done it correctly. Otherwise, if you have done it correctly, you will see this kind of a alignment grid view where you have all the data. So we have finished the modification and alignment. However, what we try to do is to follow the existing center line, and there is a little bit of a hard time here because of this compound curve. So we couldn't avoid this one. If we are going to avoid this one, then it will create problems to the existing houses. So you have to be careful about that. That is why we use this compound curve. Also, in this location we have a existing bridge. So that would be better to have a straight here, because if there is a curve, the construction of the bridge would be not easy. So far we have finalized an alignment. In the next video we will see how to create the vertical alignment. Before that, we will be learning how to create surface profiles and profile views. So also we have to know how to apply super elevation. I will be telling that in a later video. In the next video, what we will be looking at is applying the creating the vertical alignment for this horizontal alignment. So far we have created the alignment and finalized it. Now we haven't saved the drawing yet, so I will close these things and will save the drawing from here. Save. Then I will save this drawing as create surface profile. Then I click save again. Now what I am doing is I am creating what is called surface profile. Right. Now we have created the alignment on top of a surface. So we have the alignment, we have the surface. We don't have any connection between alignment and surface. By creating surface profile means we are creating the elevations of the surface just underneath this alignment. That means we are extracting the elevations of the ground surface underneath this alignment. So to do that, we click this alignment, then from the from the ribbon you have surface profile, you click here, then it is asking for your alignment and the surface is here, you click add here, then click OK. So your alignment would be given the elevations of the surface, but we can't see them. Still, we have to create the profile to see these things. So in the next video, I will tell you how to create the profile view. So what we have done is created the surface profile. That means the elevations of the surface just underneath the alignment. Before that, I will ask you to save the drawing and let us close it.
In this video, we are going to create the profile view. So we will see what is a profile view moments later. So before that, we have to open the drawing we required to create the profile view. I am going to this application menu browser and go to open here, and I will select the last saved drawing, which is create surface profile. Okay. Click open. Now this is the drawing which we created, surface profile. So I will save this drawing as create profile view. Let's click save. Now what I am going to do is create a longitudinal section along this trace. That means I have a curved road here, but I will mark the road stations on a straight line like this, and I will mark the elevations and draw a profile. That is what we are called creating a profile view. To do that, I select the alignment, go to profile view from here, you will getting this kind of ribbon. Select profile view. Then it will giving you the alignment name, and this kind of things will be appearing. You don't have to change anything. Just press next until you come to this point, and again you have to press next and click this create profile view button, and it is asking select a profile view origin. That means it is asking for a place to place the profile view. From the right side somewhere here you click. It will be the profile view will be appearing like this. So if you don't like the location, you click this profile view. Sorry, if you see my ribbon, it says multiple. That means you have selected my profile view and alignment both. So I have to press escape and again select the profile view. Then I can move it from this grip here. I can move. You have the grip here where you can move it if you don't like the place it was located. So you can see at station 0 this elevation, station 10 this elevation, because these are marked at 10-meter intervals. So you can see kind of a smooth road here, but it is not smooth at all. We getting this kind of a smooth road because we followed the existing center line, because existing center line is kind of a smooth road. That is why we are getting some kind of a smooth section, smooth road section here. So if you think of a place somewhere here, 1 plus 100 or 1 plus 110 somewhere here, you may be having kind of a odd shape. Let's see whether if it is happening. Yeah, you see some kind of a odd shape is happening here. So also you can see some places there may be odd shapes because the alignment is going outside. So that is how to create a profile view. You have the elevations of the alignment in a profile grid. So by that you can get a clear idea of the elevations of your road, existing elevations of your road. So in the next video we will be designing a new road on top of this profile view. That means we are creating a new profile. We have the surface profile here. Surface profile means the elevations of the existing alignment in that ground. So we will create a new ground or new surface to follow this existing surface. So in the next video we will look how to do that. In the previous video we learned how to create the profile view. In this video we are going to create a new vertical alignment to our road. So before that we need to know what are the guidelines we have to follow to design the vertical alignment. So we will look at that now. Since your road is a two-lane two-way road and it is on a flat terrain, we will assume that this is a B-class road. Here you can go the gradients or the slope of the road up to 5%. So you can use gradients up to 5%. So that is one kind of constraint you have to maintain in this road. The maximum gradients you can go is 5%. Then when you are going with that gradients, you have to follow the critical length. So if you are going with the 3% gradient, but the maximum length you can go is 480 likewise. Then you have to follow the curve length for appearance criteria. Since we are using the design speed of 60 kilometers per hour, you have to follow the length of the vertical curve, which is 50 meters. So you have to use the length of the vertical curve of 50 meters or higher to get the appearance criteria. So for a crest curve, you have to use the side distance criteria to be satisfied. So if we are, since we are designing the road for 60 kilometers per hour, your side distance should be 17 in terms of the K value for crest curves. That means curves like this, vertical curves like this. So we are looking only at this SSD or stopping side distance criteria. So your K value should be greater than 17. Then for crest values, you have the convert criteria. So that K value should be 9.4. So when you are comparing 9.4 and 17, definitely you have to go with the 17 criteria. Otherwise, if you go with 9.4, that curve will not satisfy SSD criteria. So in any case, when you satisfy the SSD criteria, you will automatically satisfy the convert criteria. So if you are using side vertical curves, you have to satisfy the headlight side distance criteria, which is 17. So you have to use 17 for a side vertical curve for 60 kilometers per hour design speed. So as well, you have to follow the SSD criteria. That one is also 17 for the side curve, because I told you we use headlight and SSD criteria same in that lecture. However, for the side curves, you have to satisfy the appearance criteria also. So in that case, you have to follow this one. Again, you have to have a curve length or vertical curve length of 50 meter or greater to satisfy the vertical curve length criteria for 60 kilometers per hour. So that is the kind of design criteria we have to remember when designing this horizontal alignment for this particular road. Now we know what are the criteria we have to follow to design this road. So with that in mind, we will start designing this vertical alignment. So before that, we will talk about something new in this profile view, which I forgot to tell earlier in the last video. In this profile view, you have some bands here: chainage, EG elevation, FG elevation, vertical geometry, horizontal geometry, and super elevation. Chainage means the length or station of the road. EG elevation is the existing ground elevation. FG elevation is the finished ground elevation. You can see both these elevations are same because only we have a existing ground model, existing ground profile. So it will give both elevations as same. So once we design the vertical alignment here, you can apply that vertical alignment to this FG elevation band, so that these values getting something different than this one. So this vertical geometry will also be changed, can also be changed once you apply this vertical alignment criteria here. So here this horizontal geometry, you can see we have the straights, then you have the curve criteria, 650 curve we used, and again we have a straight, then again you have a 280 curve, again you have this 300 and this 145 curves which we had earlier when designing the curve. So it is a summary of the horizontal alignment in this band. Again it shows where the curve starts and where the curve ends. This is the starting station, this is the ending station, likewise. So with that in mind, we will start drawing the vertical alignment. Before that, I will save this drawing as, first I will save this drawing and then I will save this drawing as create vertical profile and press save. So this drawing will be continued forward as create vertical profile. Now what I am going to do is select this gray lines here. So all the profile view will be get selected. Then here I use this profile creation tools, this option. So let us say our profile name is finish count. So you can have a description here if you want. Otherwise I will make these values default and click OK. Then I have to draw, we have this toolbar like we had in alignment. Now I am going to draw this vertical alignment on top of this horizontal alignment. So you have to use this tool here and go to draw tangents. So we will only draw the tangents and then next we will add the curves. So I come here. So I have to find the end point of this. End point means this zero station. I don't know whether if I click somewhere here whether I will get the end point. So to do that, what I do is I press shift key on my keyboard, then right click and select nearest. Then it will let you find this edge of this blue line where the starting station is. I will start somewhere above the small amount above the ground. Then I draw this one. We have a sag here, so I will make a sag here. Then again we have a crest here, so I will have a crest here somewhere like this. Again I have a sag here. I will have a small cut section here and come up to this point somewhere here. And again I have this sag. I will place somewhere here, let us see. Then I will have another small curve up somewhere here. I will have it somewhere here like this. So I'm just drawing to follow the ground. Somewhere here I will stop and close it. Again I press this shift key and right click, go to nearest, and I catch the end point and I will finish my row. Then press escape. So you will see I have created the vertical profile, but in this thing you have to follow a lot of things. You have to check the vertical horizontal coordination, but we don't have that much of time to check all these things. What I am giving you is an small idea about how to create the alignment. So when you are designing the alignment in a project, you have to think of all these factors, vertical, horizontal coordination and ground clearance, and whether if there are bridges, you have to check those profile at those locations also. And if you are using a cut section, you have to ensure that it will not create access problems to the nearby houses. Also, if you are using high fill locations, should not cause access problems to other nearby houses because of the road. And when you are having cutting sections, you have to ensure that you don't have culverts or flood issues when that profile is there, when you are lowering the profile. And also you have to with the flood values when you are designing the alignment. If there is some flooding at some location, you have to design your profile so that your road is going at a higher location than the flood. So those things you have to consider when you are designing the profile. What we have done here is just having the profile to give you an idea how to create the profile. So far we have done creating tangents. Now we are going to create the line, create the curves. Before that we will look at the tangents, how they looks like. You can see this is 2.0% gradient, 1.09 gradient, 4% gradient because you can go up to 5%, and 1.14, 5.42. You can't use this value. I have to change this value, so I can lower this one and raise this side so that I get something less than 5. Now there is a problem here. This specific gradient is 0.06. You can't use that gradient because you should have minus 0.3% gradient at least for at minus 0.3% gradient at least, why not minus, actually 0.3% gradient at least to satisfy drainage purposes. So what we do here is I have to increase this gradient. Instead, what I will do is I will delete this PVI point of vertical intersection, so that this gradient increases. From here I click delete PVI, then I click here. So it had some problems, it had created some problems for us. So I have a PVI again somewhere here. Just say I apply a PVI somewhere here. Still I have the problem. So I can raise this one a bit. Then it looks like okay. Again we have a problem here. So I will raise this profile and see what happens. And I can lower somewhere here. I'm just doing some modifications. I have to redo these modifications later also. And again I have this 0.21 percentage. So I will change this side. Seems like now okay. Right, now it seems like okay for the moment. So now I am going to apply create the vertical curves. So your minimum curve length should be 50 meters to satisfy the appearance criteria. So once I place the vertical curves here between two tangents, I will use the curve length option, and I will use something like 50 or 60 as my curve length. So to do that, I am going here, profile layout tool, this option, then three vertical curves, 3 vertical parabola PVI based. I click that one, then I click here. It is asking pick point near PVI to add curve. I want to add a curve here, so I click this PVI. It is asking specify the curve length. Let us say, since my minimum curve length is 50, I will type in, instead of 50, I will type 60. Then press enter, and I will see the value. So at least I should have 17 to satisfy k value for stopping side distance criteria. In this table, it gives my k value as 19.16. So that means my k value is okay. So this curve is okay. Then I am going to this point. So since our last option is this one, you don't have to go to here and click this one. Instead, you can just click this one. It will activate the last option what we did. So I am picking this point. Again, I am giving my curve length as 60, and I press enter and see whether that satisfies the criteria. Oh, that is a problem because it will not satisfy the side distance criteria. I have to have at least 17. So what I do is I click here, pick sub-entity edit, select PVI option, then this kind of a window will be appearing. I select this PVI, I click somewhere here. It is asking to point near PVI to select. I select this one. So what will I do? I do increase the curve length. Let us say I increase into 70. So my k value is 12, not enough. Let us say we increase into 100. Now it is 80. Now my k value is okay. Then I press enter to accept that. Then I am going to add the curve here. Click here. So I type my curve length as 60 as usual. Then press enter. It is okay because this k value is greater than 80. Again I come to here and press here, and so if it is this one is bothering you, you can close this one. Then I type here curve length as 60. So when I press enter, this one I need a small modification because this k value is just less than 17. So I have to increase a little amount of curve length. So I click here to get that select PVI, but I don't get that window here. So in that case, you have to click it here one and again. So you have to click 2 times. So it will be appearing. Then you select this PVI button and you select here. So you will be getting this small window. You type the value as 70 and you will be seeing that your k value is now satisfied. Now I am coming to this point. Then I in the curve again. My curve will be 60 and press enter. You will see now still that is not satisfied. I have to increase the curve length. I increase my curve length up to 70 and see still not 80 be okay. Now instead of increasing the curve length, you can decrease the gradients and see what happens also, because if you decrease or increase the gradient, these values will be changed. For example, let us say this grade out, we change it to minus 0.5. So you will see the K value changes. So instead of always changing the curve length, you can change the gradients also. So we have few curves left. I will quickly go through them. Seems okay. Okay. Again, okay, everything is more than 17, which is the critical K value for this design speed. So far we have created the profile of the road. So we have checked everything, but you can do one more thing if you like. You can round off the ratios. Instead of this having 919.39, you can change them to 120 like that. So the easiest way to do is you have to click here, profile grid view. So you type the changes here 120 instead of 326. We will type 330 here, 490. Let's type it again. This one is 780. This one is 900. This is 1050. This is 1140. This is 1280. This is 1380. And final one you can't change because that is the end of the alignment. So this is this, and you can't change it. You have to be exact with that. So you can't change this one. In the middle you can change these values. Once you have changed the values, you have to check the gradients. They will be appearing here whether they are less than 0.3, and also the K values. Once you are changing the station, sometimes these K values may be just shifted to a value less than 17 in this case. So you have to check the values here also. If there's a change, you can increase the curve length from here and check whether the values satisfy this criteria. So I will close that one, and I will close this one as well. I will close it from here. So that is how to create vertical alignment, and also I will tell you how to modify this band now, because we have a vertical profile here. To change this band data, I click this profile view, then I go to profile view properties from here, then I am going to bands tab, and if you can't see this properly, you can expand it here. So you can see for existing ground you will get EG surface. It is okay because existing ground data is getting from EG, and new road finished ground you have to take it from your finished ground where you created just moments earlier. You have to set two options here, surface profile 1 and profile 2, finished ground, and vertical geometry also. So vertical geometry here you have to set it to finished ground. So these changes will be applied to this finished ground and this vertical geometry location. So you will see these are changing while I click OK. You will see here. Now what happens here is this profile is drawn here like a summary. You can see the gradient and K value and curve length. So you have less data than here, but still you can get a good idea. Then you can see now the EG elevation and FG elevation have changed because we have changed the profiles. For EG elevations, it will take elevations from this one. For FG elevation, it will take the stations from this one, which is the profile we created for FG. So far we have created alignment for horizontal alignment, and we have created a vertical alignment, and we have set up the vertical alignment profile view band to get a clear view of the data in the alignment as well as the profile. In the next video, we will be looking at how to apply super elevation to this alignment, and then we will create the corridor and the cross sections in the coming videos. So before that, I will save this drawing and close this drawing. Save it and close it. In the previous video, we learned how to import super elevation and create the super elevation diagram. So in this video, what we are going to do is creating the assemblies, or otherwise the typical sections for your road design. So I hope you have saved this drawing by now. So I will rename this drawing by save as the drawing as create assemblies. And click save. Now I have a new file which we called with the name of create assemblies. So if you move the cursor here, something additional, something you may be shifted to another tab, so you can click here again and go to model 1, so you will be getting back to the normal view. So that is something additional. So before create the assembly, so the typical cross sections, I have to tell you what kind of regions we are creating in this road project. So let us say we have identified several regions in this road project and how they are going to be created. So now I will show you what are the regions we are going to create inside this road project. So this is our region table for the road project. So you have the road with earth drains from start to station 960. Then from 960 to 1045, you have both side concrete drains. In 1045 to 1060, you have a bridge section, and finally from 1060 to end, you have again concrete drains to the road. So we have to create the 3 typical cross sections for this project. That means both side drain, both side concrete drain, and the bridge section. You have to create 3 typical sections. At the start of the design summary, I told you In your payment design, you will be having these layers. Bearing cost 50, binder cost 50, base cost 200 and surface cost 250. For the bridge section, we will assume we only have bearing cost 50 and binder cost 50 millimeters. Now I am going to create an assembly, or otherwise we call it the typical section for the road. If you are familiar with road projects, you will know what are typical cross sections. So what we are going to do is we create a typical cross section for this road project. To do that, you go to Home tab, then go to Assembly here, click that drop down, go to Create Assembly, and you type the name here, both side drain. Then you don't change anything. If you can type some descriptions here instead. I'm not typing here. I will click OK. Then it is asking specify assembly baseline location. It is asking for a location to place the assembly. You click somewhere here. You will see this kind of a green vertical mark will be appearing on your screen once the assembly is created, but still it is only a vertical line. So to be a cross section, you have to add parts to either side of this. So you can remember you have a lane width of 3.5 lane width, 1 meter hard shoulder, 1 meter soft shoulder, and other drains and cut and fill sections. So I am going to add a lane to this assembly. To do that, you have to go here, you call it tool palettes, then you can make this larger if you need. So if you are not getting this thing, first I have to go to this lanes tab here, then I click this lane super elevation AOR. But if you are not seeing any of these in your tool palette, what you have to do is you have to close the drawing and go to your desktop. Instead of double clicking your Civil 3D metric version icon to open it, you right click the software metric icon and run it as administrator. So after that you open the drawing from that administrative open software. That means you in the desktop you right click the Civil 3D icon and run it as administrator. So that is how you make it appear if this one is not visible to you. So now I am on this lanes tab. I click lane super elevation AOR, then I click here. So it applied to my left side. So again I click here to select the sub assembly. We call it a sub assembly. I will close this for a moment. So my lane is attached, but I don't know what are the data inside this. To view this data, I select this one. So I escape to deselect it, then I select it by clicking here. Then from here I go to sub-assembly properties. So this part would be the left lane. I type it as left lane, and my parameters would be side left, which should be 3.5. Super elevation would be minus 2.5 default. My pair 1 depth could be varying coarse depth, that is 0.05 for millimeters, 50 millimeters, but in terms of meters it is 0.05. Pair 2 is the binder coarse, and base depth is 0.2, and sub base depth would be 0.25. For use super elevation option, you have to select, you click here and select. Since you are at the left plane, you have to select left plane outside. So if you can remember, when we fill up the Excel sheet to import super elevation, we filled only two columns, that is left outside lane and right outside lane. So we are telling Civil 3D to get the super elevation values from the left outside lane. So here we have to set it to left outside lane. Then you have to set this potential pivot to no, and then this inside point would be crown, and outside point is a none. Just type those values and click OK. So you will be getting this one. So your heart shoulder would be same as this one because you have the same layers, only difference would be the width. So what we do is we will copy this to this edge. So we select it, we copy it from here, and we select this top circle to catch this edge. So it will be attached to this edge. Then I select this one and go to subassembly properties, and this time this part would be left heart shoulder, not the plane. I will type left heart shoulder. So other parameters would be same as the lane, so I put them as it is. So far we have, anyway I have to do some change there. I select it again and go to subassembly properties and go to parameters because the width should be 1 meter. So that one is okay now. So if you think this is too complicated, these labels are too complicated, you can change the scale somewhere about 1:500 so that you can see them clearly. Now what I have to do is I have to mark the soft shoulder, that is 1 meter. So what we do is we mark the soft shoulder as a thin line. Instead of having these layers, we will mark it as a thin line because we will be doing a filling in that location. So if you need, you can use some kind of a layer, but I will use a thin layer or a single line to represent the shoulder here. So I select this one, then I copy it here from here and go to here. So I have copied this to the left side, so I have to change the parameters. That should be left soft shoulder, left SS, and your width would be 1 meter. But what I do is I change all the layers to 0, and there would no super elevation applied here, and default super elevation of the default slope of the soft shoulder is usually -4. So I have set those parameters, and you will be not having any point codes in this section. So I click OK. So far we have created the lane, hard shoulder and the soft shoulder. So there are several ways to create these things. Instead of using the lane assembly here, you can use shoulder assemblies as well. So when you get more experience, you can use them, but as a practice I am going with, as for the practice I am only going with one assembly so that you can get the easy idea. Then what we are talking here is, if I click here, you can see both side earth drain assembly. So what I am having is a earth drain assembly. So if you can remember, usually we have earth drains at the end of a field section, or especially at the cut section. If you have a cut section where you have some kind of a cutting situation, at the end of that cut situation you will be having an earth drain. So I will mark the earth drain here, but I will think, so I will make sure that this earth drain will be there only if there is a cut section. Only if there is a cut section you will be having a drain, otherwise you will be having a fill only. So I will describe it just in a few minutes. So to get the earth drain assembly, you have to go to tool palettes, then you go to trench, and then you go to ditch assembly, and you click it here. So you will now see some kind of a long section assembly is appeared. So this is called the ditch, but this is a very large assembly, so we have to modify the parameters to get the required drain from here. So to do that I will modify this. So I click this one, and I go to sub-assembly properties. So I will type the name as ditch, and so it will be applied only, include ditch only will be at the cut section, and I have to fill some more parameters here. So once you fill out all the parameters, it would be looking like this. You can fill out these parameters in your assembly also. So I will click OK now. So it will be looking like this. The drain will be looking like this. So if there's a drain, it will be looking like this. Then after the drain you have to add the cut and fill. If there is a cut, it will be going like this. If there is a fill, it will be going like this. Actually it will be not going from here, it will be going from here, because we say this ditch will be included only if there is a cut section. So to add the cut and fill, we call it the daylight. So we have to go here, then you go to daylight, then you go to daylight bench, then you click this point. So you will be getting a daylight bench assembly. So I close these things and I change the parameters of the assembly. So it should be left daylight bench, and this cut slope would be 0.251, max height would be 4 meters, fill slope would be 1.51, the max height cut height would be 4 meters, bench would set as a 1 meter, bench slope 2%. So that are the values we have to type in, and then press OK. So you will not be seeing any change here, but the changes are readily modified into the assembly. So then you have to fill the right side, same as we did for the left side. Instead what we do is we select all the assemblies from left to right, right to left, like this. Without this green one, we have to select these things only. Then we click mirror here. Then it is asking what is the mirror assembly. We click somewhere. Here you will see it will reflect to the other side, but you have to do some changes, because if you click this one, you go and it is not left lane, it is right lane. Again, this would be super elevation at the right lane outside. Click OK and I press escape, and then I go to hard shoulder. It should be right hard shoulder, and these are the values, and this will be right lane outside. Press OK. So this one will be right soft shoulder. Values will be changed in the soft shoulder, and this will be right side ditch, and finally this will be right daylight edge. So we have created the first assembly here. You can see these are the representation with assuming that this is 0 elevation. So if you apply super elevation here, minus 2.5 with a width of 3.5, you get these values. So I have to tell you one thing, I forgot to tell that thing earlier. In this assembly, you have to go to sub-assembly properties, and you have to change the point code from edge of lane to inside point code, and edge of payment ETW to outside point code. So this part also you have to do it lane and TW. So that is the change you have to do. So once you do that change, you will see this label appearing in that location. So we have now completed the earth drain part. In the next session we will create the bridge assembly and the concrete drain assembly. In this session we will be creating the other two assemblies we needed, that is the assembly with concrete drain and the bridge assembly. So we are still continuing the last drawing. So to create new assembly, I go to home tab, then go to assembly and create assembly, and this time it should be both side concrete drain, and I click OK. So I will be clicking that somewhere here, create the assembly. So in the concrete drain assembly also, you will be having all these three sections: plane, hard shoulder and soft shoulder. So what I can do is I can copy these things to this assembly, except this drain part, earth drain part and daylight part. So what I do is I select, put my cursor somewhere here, then I select these three only. You can select one by one also, like this. I press escape, I select this one, then this one, and then this one, like this. You can select, then you press copy and go here. So by this method you don't have to change any names or anything, because they are already there as in the sub-assembly here. So then I copy the right side to right side here. Just click here, right side will be copied. Now what I am going to do next is I am setting the concrete frame here. To do that, I will go here, tool palettes, then I go to French tab here, and I go to side ditch U shape. So I will attach it to the left side first. So this is the default assembly we got. I press escape and I close this one. Then I have to do some modification to this to get the required grain. So I click here, then I go to sub-assembly properties, then this is left side this U shape, and I have to change these parameters. So I will change these parameters now. So once you fill out all these sections, you can with these values, you can fill these values on your assembly also. I have used this 1 millimeter values because I can't use 0, it will get you an error. Instead you have to have very small value. I have put 1 millimeter to show you the value. So even you can even put a value such as 0.00001 to get something close to 0, but you can't type exact 0 because it will give you an error. So if you need to know more about assemblies, you can click help here. So it will show you all the help on related to this assembly. So you can get the help from any assembly you work with from here as well as from here. So sometimes it may not be working with you if the help files are not installed in your computer. So in that case, you can go online and search for the help files, or else you can download the help file. So since we have completed this part, I will click OK. So you will see this kind of a drain appears here. Then what I do is I am going to have the daylight part at the end. So I will copy it from here. Copy and click here to set it to here. Now what I am going to do is I will mirror this. So I will mirror this one only. So I click this one, then click mirror. So if you don't see mirror here, that means let us say if you click something else this side, so mirror will be disappear. In that case, you have to press escape and click it again. So I press mirror and I will mirror it to this side, but I have to change the name. Go here and change the name as right side ditch left. Then I copy the daylight assembly from here to this point. So I copied it from here, and if I mirrored it from this point, I have to change the name. If I copy it from here, I don't have to change the name. So now what is left is only the bridge assembly. So I will do the bridge assembly in a separate way. So what I do is I click copy here, then I select this assembly, then press enter. It is asking for a base point. I select this, select somewhere here at the bottom, then I paste it here, or second point I will paste it here, then press escape. Otherwise you can select all these things, right click copy and do the paste, and it will do the same thing. Now I have done it. So now what I am going to do is I am having a big assembly. So I don't need these things for a bridge cut and fill. So I will delete these two by just pressing delete button after selecting it. I will not be having more things also. So let us say I have this for foot rope, these 1 meter sections. So depending on the big section, you may have some kind of a larger value. So you have to use those values from the typical cross-sections from the big engineers. But I will keep strict to the current values. Now in this you don't have ABC or the base course or sub base in a big section, so you have to remove those layers. So I will tell you a quick way to remove those layers. If you see all these sections, you have same layers. What I do is I select all of them like this, then right click, go to properties, then from here I drag it to here. From here I change it 0 and 0. Those two layers I make them 0. Then I press close. Now we only have a bearing force of 50mm and binder force of 50mm. But still I have to change this name of the assembly. So I click here because my name is both side concrete drain 2. So I have to change it to bridge assembly. I select it here, go to assembly properties, and I change the name as bridge assembly and click OK. So then I press escape to deselect that one. So far we have created all the assemblies or the typical cross sections. That means the drains, concrete drains, and bridge sections. In the next video we will be looking at how to create the corridor for the road trace via design.
In this section, we are going to create the layout of the road before creating the corridor. This can be done even at the start of the alignment, even after creating the alignment, but I will do it at this moment before creating the corridor. To do that, first I will unload this XREF. To do that, I type XREF in my command line. Then I select this topo survey and click unload. So it will be disappeared for a moment. Then I click close. Now I will do something called offsetting the alignment. That means we are creating the lane edges, hard shoulder edges and soft shoulder edge to represent the layout of the road. Before that, I will change my scale to 1:1000 so that I can get a bigger view of the window. To get the offset alignment, I will select my alignment. Then from here, select offset alignment. So we have 3.5 lane either side of the road. So our lane is from start to end. So we have one lane to the left, one lane to the right, and the lane width is 3.5, and the other lane width is also 3.5, and the alignment style would be new road offset. Alignment style means how this alignment looks like. So in this alignment, it is looking like red and blue. You can see straights are in red and curves are in blue, and this is the style we are going to use for the offset alignment. We will see how it looks like once we press OK. So I press OK. So then it will create two offset alignments at the 3.5 distance from my center line. So you will see it was now created. Even though this has two colors, red for straight and blue for curves, but this offset alignment has only one color. That is how it is set. Now we are going to add the hard shoulder to this offset alignment. So before doing that, I have to tell you this: if we are still on the create assembly drawing, I will rename it as, actually I will save it as create layout of road. Then click save. So we are going to continue this drawing with a separate name. That's only difference. Then I am going to have the hard shoulder here. The hard shoulder is 1 meter from the plane edge. So I click a plane edge offset assembly. Then I go to offset alignment. Then I go to offset alignment here from the ribbon. So this time we will have the offset alignment to the left side only, because you can't come into the right side because it is the plane inside the right edge. So we will be having only on the left side, and it is 1 meter, and we will stick with the new road offset style. So you get that. Then for the right side also you do that from here. Then your left side would be 0 and right side would be 1, and the increment would be 1 meter. So now you have two lanes and two hard shoulders. Then then I have to mark the top shoulder, which is also 1 meter. It would be 1 meter from this. So I click this one and I go here and mark one for left side, and it would be 1 meter. And for the right side also, I am going to the right side now and mark it as 1 meter. So if you need, you can have separate styles to these lane edges. For the moment I will stick to one alignment style. So we have something new in this page, that we are going to slightly change the layout of the lanes because of a bus bay. So we'll assume we have a bus bay inside this road. So we have to model that bus bay also within this plane arrangement. So first we will look at how the bus bay comes into this drawing. So this is the typical arrangement of the proposed bus bay. It is from 0 plus 820 to 0 plus 868, and it will be at the RHS, that means right hand side. This is the layout. We will be having a 18 meter transition, and then you have the bus bay with 12 meter, and again it will transit into the hard shoulder, which should be hard shoulder with 18 meter. So this height would be 3 meters. Actually this width should be 3 meters. So the bus bay would be 3 meters in
width. So altogether you have 48-meter long bus bay. We have to model that inside the lane arrangement. So we will see how to model that now. Now we are going to find 820 point in the drawing. This is where we have 820. Then what I am going to do is I am widening my hard shoulder so that I get the bus bay. So this is how to do it. You click this hard shoulder because it is the bus bay is at the right side. My chain edges is increasing to this side, so this side is the right side. So I select the hard shoulder of the right side. Then I go at widening this one because at the bus bay your payment would be widening. So I select here. Then it is asking on the command line create widening portion as a new alignment. Let us say no, you click this no. Then it is asking what is the start station. So it will be started. So the full widening, that means the full width of the widening will be started after 18 meters. That means from 820 after 18 meters means 838. So I type 838 here. So that is where my full width starts, and then it will be end at 12 meters. That means 850. So then it is asking what is the widening offset. So this time the widening offset would be how much from the center line. Up to this point we have 3 point plus 1, 4.5, another 3 meter means 7.5. So we have to mark the width from the center line. So you will see how it gets widening. Actually I have done something wrong here because it has widening from the center line, not the center line, it has widening from the main this one. So I have to change it. This should be 3 meters. Sorry about that, I just forgot how it went. So this should be 3 meters now. So you can see this has been widened for 3 meters. Now I will assume so in the layout we saw we have a linear transition of 18 meters. So I will select this entry as linear. So I change this value here, you can remember to 3 meters. Then I have a linear transition at the start and linear transition at the end, and the transition length would be 18 meters both sides. And you can see when you change this length, my start and end stations are changing. So my start station was 838 and my end station was 850. Now that those are okay, I click close. So now you can see, if I press escape, you can see I have widened the hard shoulder. You can see when you widen the hard shoulder, your soft shoulder which is going outside automatically stays with the hard shoulder with a 1 meter gap. So that is called the dynamic behavior of Civil 3D. Once we updated one thing, it will automatically update the other related locations also. So now we have completed creating the layout of the road. In the next video we will be going to create the corridor of the road. We have created the layout of the road up to this part. Now we haven't saved that drawing. I will save the drawing now. I click here to save the drawing. Then what I do is I will create this drawing with a save as with the name of create corridor. Now we are going to create something called a corridor, that is the 3D model of the finished gown what we are working so far. We have created the horizontal alignment here, we have created the vertical alignment here, and we have created the assemblies here. So using all these three parts, we will be creating a 3D model of the new road we are going to construct. So that is called creating a corridor. To do that, I go to Home tab, then I go to Corridor, then I name the corridor as Final Corridor. Then my alignment would be my design road alignment, which is the alignment of the center line. You can select the alignment from this button also. If you have so many alignments, you can use that button to select the correct alignment. And your profile would be, I will select it from here. You have to select this red and blue one, that is the design profile. So it is the finished ground. You can use this drop down to find it also. Then I will create the whole road for this road drain assembly, and then I create the target surface as PG. So that means when you are having a fill situation, your fill stops at the ground. So target surface means where when the fill condition is applied, when the fill is coming, it will be going down up to the existing ground. So this target surface is given to catch the existing ground for the assembly. So I click OK now. Now if I expand it a little bit more, we can see clearly this is the name of the corridor region, this is the alignment, this is the profile we gave, and this is the assembly, and this is the start station, end station, then the frequency. So I will give some more detail after creating the corridor. At the moment I will click OK to create the corridor, and I click rebuild to create my corridor. So you will see something is happening at the bottom. Our corridor is created. You can see something is created here. I will select this magenta color line, and then I go to Object Viewer, and I will just zoom this one a bit so that I can see the things clearly. I will change the style a bit. So this one, you can see what has happened here is, here you have the center line of the road. So you have the profile of the road here also, because profile is drawn over on the center line. Then what we are doing is, when creating the corridor, you are placing those assemblies we created in the assembly creation section at the interval specified by us. So that means you can see these are at kind of some interval. So placing those cross sections at a prescribed interval, and then we link those cross sections of the typical assemblies using lines, and it will give us a 3D model. So that is called the corridor. So you can find, so here little more, you can see these cross sections are placed on the alignment at the interval. This interval is called the frequency of the corridor. So you can define how much frequency you use to create the corridor at each section. That means at straight how much frequency, at curve how much frequency. So also you can see we are connecting the top part from top part, then the middle to middle, bottom to bottom. Like that we create a 3D model of the road. So that we call it the corridor of the road. So in this creation of corridor, we will consider the super elevation also. You can see we have a curve here. You can see this part is super elevated to the left side because of the curve. That means this corridor is getting super elevation from the alignment also. Right, I will close it. Now we have some idea about the creation of corridor. Then I will explain how the frequency is applied to the corridor. To do that, I select this corridor. I will select it somewhere from here, from this magenta color line. Then I go to corridor properties. Then I go to parameters tab. Here you can see my frequency is 20 meter. Frequency is 20 meter. So that means I will be applying the cross sections at 20 meter intervals. So if you like to change it, you can click it here, and you can click the you can change the settings here. So at this point, along tangents our sections would be placed at 20 meter intervals. So we'll change everything at 10 meter interval. And these points we will say no. This will make sure that this one for profile curves give it a larger value like 100. So just type these values. Just if you like to learn it Civil 3D in depth, you can learn them. You can learn why these things are changed like this in these windows. But for the moment, it is okay to have these values like this. Then I click OK. And again and rebuild the corridor. You will see more frequency lines would be appearing here. So now they are appearing at 10 meter intervals. Here you can see in between these magenta color lines are the frequency lines. You can see they are at 10 meter intervals. Now everywhere initially they were at 20 meter intervals. So that is how you create the corridor, but still there are something to be modified. Because at 820, I said we have a bus base, so our window should be modified like this. Currently it is not modified because you can see this area you don't have the actually this area you only have the road up to 4.5 and this soft shoulder, but it should be widening up to this point. So if it is correctly widened, this green color line should come up to this point, and this magenta color line this should come up to this point. So currently it is not matched. So in the next video we will be going to match these things to the correct targets. We call it target mapping. Before that we will save this drawing. In this video what we are going to do is we are going to set these targets, or we are telling Civil 3D to target the alignments to create the corridor. That means like this. I will turn off this corridor for a moment. To do that, select this corridor properties, and from here I click this button to turn off the corridor and click the key. We build the corridor. So your corridor will be turned off. Now by target mapping, what we are doing is we are telling Civil 3D to get these targets. So if I go to my assembly, this is the assembly we use to create the corridor. This one, that is both side drain. So first I have my plane edge, then I have my hard shoulder edge, then I have my soft shoulder edge. So if I select this one, this should be right plane, this should be right hard shoulder, and this should be right soft shoulder. So what I am going to tell Civil 3D is right plane should catch this offset. That means design road right minus design road right 3.5. Then hard shoulder should catch this one, and the soft shoulder should catch this one. So this is how to do it. Now since my corridor is turned off, I can turn it on by clicking here. In my prospector, I go to corridors. My corridor name is final corridor. I right click and go to properties. Then I can turn on my corridor. This is how I turn on the corridor. Now you can see currently these are meshed because there is no width changes at this point. But at this 820 location there is a width change, so this is not matching. So what I am going to do is I tell Civil 3D to catch each alignment to target the lines of the assembly. So I click this corridor and go to corridor properties. Here I go to target and I tell my left plane to select the left minus 3.5. Okay, minus 3.5. I select here, then go up, then it will coming down. Then I select okay, so yeah, I will see that it comes here. Then my left half shoulder would be 3.5 left 1. Then I click here to add it, click OK, and my soft shoulder would be this one. And for the right side, my right lane should be height 3.5, and right hard shoulder would be this one, and height of shoulder would be this one. So I have set all the targets. Then I click OK. So my corridor will be rebuilt. Now you can see at this location, all these are now clearly matched. So my width is there correctly matched. So that is what we done by target mapping. We call it target mapping. But up to this point we haven't saved the drawing. So I will save this drawing as target mapping and click save. So up to this point we have created the corridor with correct targets. So the target mapping section is now over. Next, we will see how to split the corridor, because we have to have those regions inside this corridor, because you can remember in the start of this section I told you your regions are this both side drain, earth drain, you have this region, then you have concrete drains from this region, then you have beach in this region likewise. So in the next section we will do something called splitting the corridor to change the to have the correct regions. In this video we are going to learn something called splitting regions, because we have a set of regions in this road. So we have concrete drains, we have earth drains, we have a bridge section. So if you recall the region table which I gave you in an earlier video, you can see there are three cross-section types, and actually there were 4 corridor sections in this road. So by splitting corridor, what we do is we are creating 4 corridor sections in this road. So to do that, you click, before doing that we will save this drawing as splitting corridor. Click save. Then I select this corridor somewhere here, this magenta color line. I select the corridor. So once you select, you can confirm it by having this name, because our name is final corridor. So I go to here, corridor properties. Then on the parameters tab, I select this region line and right click. So you have to select the bottom row. Then you right click and go to split region. Then you have to type what are the regions you have to divide this corridor into. So up to 960 you will be having earth drains. Then 960 to 1045 you have concrete drains. Then 1045 to 1060 you have bridge section. Then 1060 to end you have the concrete section, so you don't have to split the end point, just click enter. So you will see our regions are now divided by splitting the corridor. Now each of these sections, currently my assembly is both side earth drain, but you know from this, for this section, assembly should be both side concrete drain. This is how to change it. You click here and you select the correct assembly. Click OK. Here it was bridge assembly. Here it was concrete drain. So that part is okay, but we have to make sure the targets are also correctly placed. So in earth drain we set the targets. So if you go to this target bar, you can see the targets are set because you will see all the names here correctly. So but if you go to concrete drain, you have to make sure the targets are still there because we changed the assembly at this point. So you go to targets, you can see even though you have something to left lane, it is wrong because for left lane it should be design road left 3.5 only. So these targets are wrong. You have to define them. Then you click here. This should be removed. So I click here to remove it. Then your left should be this one. Click OK. Then your left hard shoulder is this one. Click OK. And soft shoulder is this one, and I click OK. So this one, and I click OK again. So for the right side also this is not the correct one. I delete it and I set the right values to these lanes with the correct target mapping. So far we have done with this one. Then I go to the bridge assembly and this has the same problem. So I will change the things according to the correct version of the assemblies. Here also I have to change the soft shoulder. Then I go to right plane. So I have changed all the parameters now. Everything okay. Again I have to go to the bottom one, which is the concrete drains. Then I will delete this one, and again I will complete all the parts correctly to get the correct mesh on the target. Okay, now everything is okay. So I click the OK button. So you can see you have a bridge section here, you have concrete drains here. So you don't see that, but it has been applied because you can see from the bridge section here, you don't have much corridor here. So that means you have the correct targeting. Also you can see that soft shoulder is not available in the bridge section because in the bridge section you don't have a soft shoulder, only you have the hard shoulders. So far we have now created the corridor regions by splitting the corridor, and we have set the correct targets. Also in the next video we will be looking at how to create the corridor surface. Now in this video we are going to look at how to create a corridor surface. Before that I will save this drawing, this splitting corridor drawing. So it will be saved, and then I will save as the drawing as create corridor surface. So creating corridor surface means something like this. If I select this corridor and go to object viewer, I told you earlier, a surface means a flat plane. So what we are doing by a corridor surface means what we are doing by a corridor surface is we are connecting the top points of these cross sections. You can see the cross sections are applied at 10 meter intervals. We will be connecting the top points of the cross sections for the assemblies, and we are creating the plane connecting all those top points. So that plane is called a corridor surface. We call it corridor top surface. The surface which is created by connecting the top points of the corridor. So we call it corridor top surface. So when the connecting points are called top chords, so we are connecting the top chords on the assemblies and creating the corridor top surface. So I will close this one here. So here to create the corridor surface, you have to select the corridor and go to corridor properties. Then I have to go to surfaces tab. Then at the left corner you have create corridor surface button. When you create the corridor surface, since then you automatically you have a name for the corridor surface. So it will be a top surface, that means we are connecting the top points to create this surface. Your surface style would be border only like this edgy surface. Then we are connecting the surface we are creating the surface by connecting the top chords or the top points. Then we add it here so that Civil 3D knows we are creating the surface from top points. Then just have a tick here to add as break line, and then for top surface just change this to top planes. Since we are creating a surface, we have to define a surface boundary also. So you have to go to boundaries tab and then right click this surface name and use corridor extent as outer boundary and click OK and rebuild the corridor. So you will see if I press K, there's a surface at the outside of the corridor. If you click here, you will highlight a surface here, final corridor top. So if you go to object viewer from here, you will see that surface. You can change the style and see how this is the top corridor surface. You can see here at the section where you have bridge, the corridor is bit contracted inside. So that is how the corridor is created with top surface. So that's about corridor surfaces. In the next video we will be looking at how to create sample lines and section views. So that will end the Civil 3D session after we create the cross sections, and in the next video we will see how to do that. Before that I will save this drawing before moving on to the next session. In this video we are going to create sample lines and section views, or else the cross sections. In the last video I told you to save the drawing. If you haven't done that, you can save it now, because we are going to change the name of the drawing. So once you change, I go here and save as the drawing, create sample lines and section views. Now what I am going to do is something called creating sample lines. The sample line means that is the locations where we get the cross sections. So a sample line is used to gather data inside that area to create the cross section. So cross section would be displayed on top, depending on the cross section of the sample line location. So we will see how to do that. So you have to go to Home tab, go to sample lines from here, then you have to select this center line. If you can't select this center line straight away, you can press enter to select from a list. So you have so many alignments because of this offset alignments, but you have to select the center line. The center line is design road. So you click OK. Then you will have the data which is available to sample for this surface, because when you are going to create the sample lines, we have to give data to the sample line. So it will show us the available data in the drawing, surfaces and corridors. So it will let us see all the corridors and surfaces here. But for the moment I will skip one and go forward to show one more additional thing in a later part of the video. So I will skip one, that is the final corridor I have skipped, and I click OK. Then a small toolbar will be appearing here. So you will see here small toolbar. From here you have to select by range of stations. You have to go to this drop down and select by range of stations, and we are having the sample lines from start to end. So if you are not going to have sample lines from start to end, you can modify it by making it false here. But currently I am making it true because I simply use complete code section to create the sample lines. Then it is asking left short width, that means how much to the left you need sample line. So the best thing is to get the length more than the corridor. So we will be thinking this 30 meters is okay. Then again you have the right side. So let's say 30 meters okay. Then it is saying at what interval you need these sample lines. So we say all at 10 meter intervals, and these values we are not going to change. Then I click OK. So you will see the sample lines are created at 10 meter intervals along the corridor. So I click here to close the sample line toolbar. Then you can see all the sample lines here. So suppose we forgot to add some data to the sample line. If you can remember, I purposely avoided one corridor without adding to the sample line. So let us say if we have forgot one corridor or one surface to add the sample line. So in that case you can go and add it again. Now I am going to add that Now I am going to add the skipped corridor to the sample lines. So I click here. Then I go to sample more sources. So in the left side we have the available sources. This source for the final corridor I have a sample into the corridor to sample line. So here I click add, and I will change this style to new road assembly labels, and click OK, and finally click OK. So once you select one sample line and add some data, it will be applied to the whole sample lines. So I press escape to deselect the sample line. So what will happen is, at this point the sample line take all the data to the sample line according to the sample data. So we have sample e.g. existing ground surface, corridor top surface, and corridor to this sample line. So it will be having this data inside this. Now what we are going to do is create section views from these sample lines, because without sample lines we can't create cross sections. Now to create cross sections, I go here, section views, then I go to create multiple views. Here it will be giving the available data here. Since we have only one sample line group, we show the only sample line group. You can change these things if you need, but we will go with these sections. Then we create next here, and also we are going to place this draft section views without creating any sheets. And to press next again, and next again, and next again, finally again next, and you have to change the values like this. You have to change it, final corridor top, final corridor top, final corridor top, and finally EG. And I am going to create section views by creating here. So it is asking where you have to place the section views. So I will be selecting somewhere here. Here you have enough data, enough space to view the cross sections. I will click here now. You will see a set of cross sections will be drawn in my civil 3D. So you can see they are drawn, but it looks like they are very staggered. So I will select this scale 1:200 so that it gives more detailed view for me. So you can see here we have the cross sections created now. We have the lanes here. Then you have the small drain here because of the cut section. This cut section appears because it goes inside the ground. You can see you have this cut section. Some of this data you need to manually modify because you can't have a section like this. In that case, you have to trim off this drain somewhere here, and this part will not be there. So we have to do manual modifications. So if you are getting thorough with Civil 3D, you will know how to do the things without making much of these modifications. So that is how we get these things. Here also we have a problem, little bit of a problem. This part will not be here in the actual case. So we have to modify before sending these things to site when you are preparing the final drawings. So if I go furthermore, and one more thing I have to tell you, this here you have the labels of the final ground. Here this is the finished ground elevation at 10410 station. So if you check the finished ground elevation, it would be 27.912 at the center. Let us check it. 410. Here, finished ground 27.912. Likewise, you have all the data nicely visible inside these cross sections. In here, you should have the existing ground data, but currently it looks like you don't have that data. So I have to modify the cross sections. To do that, I select this cross section. What I am doing is, right now is, I have the offset and existing elevation. This existing elevation band is not that clear for me. So what I am going to do is, I select the cross section, go to view group properties, then I go to this, I will expand this tab, expand this column, then I go to change band set, and I will see what is here. So should be, I think you have to use both these things, and this one should be PG always. I think that is how to correct that one. Yeah, there we go. Now we are getting some data in the cross sections. Yes, now we are getting some data in the cross sections at 10-meter intervals. Existing ground data at 10-meter intervals. If you need, you can make more ground data here. So if you are getting thorough with Civil 3D, you will know how to do these things. But as a demonstration, I will stick to these simple things. So if you can remember, at 960, we go to the concrete drains. You will see these concrete drains are now appearing from 960. In 1045, you will be having the 45 and 50. Here you have this bridge assembly. Actually, it seems like the bridge assembly is not, it is 1050 actually here. Somewhere here you can see now they have the bridge assembly, and also you can see we have only 2 layers here, and also you can see you have the super elevation values in these drawings also. Here you can see the super elevation transition sections, then you can see the full super sections. You see these values are applied to the corridor. You can see again the transition section. So those are the cross sections we created. So that is a brief introduction about creating or designing a horizontal alignment or designing a road design for a road project with Civil 3D. But this is a very simple introduction. So Civil 3D is much more than that. And also, depending on this very limited time, so we can't go to more detail. So if we were in the classroom, we will be only having 1 day to do all these things. So if it was so, sometimes we may not have time to do all these things. So I think we have done a lot of things with this limited time. but there are a lot to be learned with Civil 3D. If you wish to learn more Civil 3D, or if you are currently doing work with Civil 3D, you can refer some other tutorials, videos from YouTube or other internet sources to get more idea or understanding about Civil 3D. So that will conclude the part of Civil 3D, and again it will conclude the highway design session for this CE 760 subject. So from the first video and up to this last video, we have learned so many things about highway designing and Civil 3D, and how to do a small project with Civil 3D software. So if you are going to design a highway, you have to follow the design guidelines. You have to follow them as much as possible. So just don't think you can create a road by just looking at the survey data and looking at the site. So many things has to be followed. So you have to follow the design concept which I told you in the earlier lecture series. So how to select things, how to do the trial alignments, and how to apply the super elevation and select the curve radius, how to cope with the constraints. All these things you have to consider when you are designing the road, without just considering drawing a line or curve on the Civil 3D software, and that is not highway design. So if you have any problems, you can ask on the session on the Zoom lecture session at the next class. So I will hope you get some good information and good knowledge from this lecture series, and good luck with you, and I'm looking for your questions to be answered in the next Zoom sessions.